Hi guys, welcome to part 21 I believe of our Formatables Refactor. Need a bit of coffee I think to get going. So we're recording, we are. So we were, as I said on the previous video, we needed to do some work offline. The reason why was because some of the stuff that we were working on was actually quite hard to get our heads around really. And it was easy to just sit down and think through, get it more or less working, and then when we get to the part that's more mechanical, it's easier to talk and code at the same time, I think. So where are we then? We created the helper. So these are the 4 bits that we need in order to generate helpers. And we generated them, and that's fine. I mean, that's just pretty much the skeletons at present, but that's alright. And where we were was we were trying. So there's 2 problems at the moment. The first problem is the factory is not actually providing us with all the information that we need in order to construct the helpers. We still need to hook up the factory into the existing PMM infrastructure. And then because we can't use the same name for the helper as we got for the new helper as we have for the existing helper, there's going to be a mismatch between the 2. And one possible solution for that mismatch is just to simply provide the helper generator in the new helper as a parallel infrastructure. And if we were to do that, we can still keep the registration as it is, more or less, and then we can go all the way up to the point where we can just have a diff between the new helper and the old helper. And if it look very, very similar, we could possibly just drop the old helpers and the new ones, or we could possibly just point the old ones to the new ones or something. I don't know. We can do a side-by-side sort of test to see how far we are from the code that's being generated. So that's one problem. One way of doing this. We still, of course, have to generate helpers for all of them. So that's another exercise that needs to be done. And of course, then the second problem that we have is that the helper has a template. Well, not that guy, but this guy has a template. And this template is not kicking in just yet. The reason why it's not kicking in just yet is because the rendering transform did some assumptions in terms of what to render, and so that's where we're going to start today, really. So where we're going to start is by looking at where we were in the rendering transform. So we started off by doing a little hackery here to convince the rendering transform to do the transforms correctly. But this hackery did not go too well. I tried to work on this here and there, but it was needed a bit of focus. I feel a bit tempted to just simply so let's call this on rendering. Let's just have a look at rendering as it stands right now. Actually, I've done a few updates to Emacs, and I think it's something not quite right with my completion just at the moment. I also are not in the right mode, right keyboard. Yeah, as you can see here, this company completion is not coming from LSP for some reason. LSP is clearly enabled because you can see the errors and everything. But ever since I've done this update to Emacs, it seems that we lost our lovely completion that we rely on so much. I haven't got time to really start playing around with that, so I'll leave it at that for now and then worry about it later. So the problem then is we seem to be focusing only on archetypes when we really need template-like thing, so I think this probably could be expressed slightly better in the logical model. I should think, of course we are abusing a little bit concepts here, but it seems to me there's another concept here called templatable. Another object template, presumably. And were we to create a templatable, we could just use that concept, anyone that requires text templating. And what else do we need besides templating? We need to get the logic templates, fine, we need a model. And then we need the content. So let's see what we did on our patch, on our stash. So we started going down this road, I think. You can see here. And then we modified as you can see here, we just basically have a single function, takes the model and the text templating, there's the computations, and away we go. Where things went a bit wrong, I think, was when we tried to do something similar for Stitch. So it works alright for whale, but doesn't work very well for Stitch. That was, I think, where we were. So maybe perhaps I was wrong. Let's just reapply this stash and revert where required. So I think when we are attempting to render the Stitch template, actually, let's see if we ever did notes in our notebook. Need to use the template method or supply the element pointer to get access to the dependencies. Okay, so that was the problem. We needed the dependencies, which also reminds me, I don't think we're populating the dependencies. No, actually, I think you mean the decoration of the dependencies. So yeah, I think we mean the decoration. And I think we're going to find that a decoration at present is an element property, which you can see here. So, what is the easiest thing to do here? Well, we could, of course, supply the decoration properties, right? Nothing stops us from doing that. We don't seem to need the configuration, so let's just do that then. Let's do a few changes here. So where we're rendering the Stitch template, let's say we don't need a configuration, but we need something like this. Now, are we in the logical model? So that'll probably be something like entities, I suspect. By reference, decoration. Right, so the idea now is that we supply the decoration, we don't bother with the configuration. I probably need a few enums here. But first let's just get this working. I think that should take us there now. Right, so the idea then is we supply the decoration, which means we no longer need to access the archetypes decoration. We clearly need to supply some kind of ID as well. Interesting enough, we don't seem to have a whale template, so we will need one of these. Okay, seems like we are getting some kind of compilation support. Now we know what this is, so we can just call it whale template with T. Right, now then, definitely have a problem with ID, but we do have a logical ID, so I think here is just usual morning. So let's call this lid. Suspect this should be dot value. Okay, that's interesting. He seems to be unhappy with our map. Not tell you why. Perhaps the well template is not what we think it is. Ah, okay, right. What's this then? It's an optional logical name, so it's going to be something else, isn't it? Well template content. Okay. And now finally we can make a few changes here. So to render the stitch template we will need a decoration, which is going to be something like the archetype dot decoration. We will need, well, we were supplying the well template before, but now we're supplying the TTs, and besides, this thing here is not returning anything, I don't think. So we could just say that post auto reference well template. Actually, we're not really supplying the well template, it's supplying the TTs, right? So arch dot text template. I thought it was text template, not text templating. Let's see anyway. Oh, redefinition of TT. Ah, okay, right. So we don't need to redefine it. And now we just need the ID. So if I say something like this, we should be there. Okay, so we're actually not that far off. So okay, so what you should do is literally nothing. Nothing should change. We are doing exactly what we were doing before. We just generalize the methods so that they largely take the same arguments for helpers as they will for archetypes as they will for helpers. But what we're going to do as well is let's not be lazy here. Let's take away all the things we have here that are not needed in a loop. And I think we're going to have a problem with the relation status actually, because we definitely need to populate this correctly, because otherwise you can't generate the header files, I don't think. So that's going to be an issue, but let's just break one thing at a time, I guess. Right, so let's run the test then. If all goes according to plan, at this point we'd expect nothing to change. Okay. There is a change. Ah, okay, we broke something. Okay, that's good, that's fine. All that's happened here is we seem to have stopped resolving some properties. Okay, when we are instantiating the well template, I think. I did say rendered well template, didn't I? Because there is a non. Ah, okay. I think this is the wrong one. Is there like a rendered? Okay, this is not having. I actually wonder what's happening at the moment with completion. This might just take a little while, but let's just do this quickly. Let's just say company mode list backends. Let's see if we can figure out. So let's just have a quick look at what company backends is saying at the moment. So control HV company backends. Okay, we go. Company backend is buffer local variable. No, okay, control HV company backends. Right, so yeah, cap F is there as you'd expect. I don't know why of company C make, but it's fine. Cap F is here. So cap F should be the thing that gives us LSP. That being the case, not obvious. What could be wrong here? Let's just have a quick look. Actually, I'm going to create an area for LSP. What are we doing in area 9? This probably. Let's do something on area 8 perhaps. I don't think it's used yet. And in area 8, let's just look at LSP. LSP log perhaps. A lot of cancelling text document. This looks a bit suspicious, doesn't it, really? Let's just do a LSP restart. Never knew the difference between LSP workspace restart and LSP restart workspace. Let's try that one. Just gonna restart the LSP driver. Oh, looks like we have sound on. Okay, looks like the restart is done. Much better. Okay, it seems like it was just some kind of LSP misbehaving sort of thing. It's not even worth clocking this as an Emacs time. Now then, so if I just basically say, what have you got on whale template content? Is there like a rendered? Now I'm getting a bit confused actually. Okay, but there is no need to get confused. We should just have a look at what we had before. Like sometimes I actually find it easier to just do a control of x equals. Of course it always goes to the wrong place. Be nice if it did and where we expect it to be. And look at the diff and visit diff. This is easier to read than the magit diff I find. And now all we need to do here is to try to understand what should we be asking for because I'm pretty sure. Oh, okay. I think probably what's happening is. Yeah, I know what's going on here. We just did something very silly. Right. Okay. Fine. We didn't really have a need for keeping the template inside of the member variable because it's only used internally. So what we've done is we broke the logic. That's fine. So what we need to do is we need to make sure this guy is returning the template. The rendered world template. We need to capture that rendered world template as it comes out of the method as we were doing before. Let's call this the rendered world template, and that's why it was called WT. Now you see what was going on here. And then, sadly, we need to also supply that And I suspect instead of the text template, because I bet you we're not doing anything with the text template. This should give me an unused parameter, hopefully. It's not, so what are we doing with it then? We are obtaining the stitch template content. Right, fine. Seems like we can't win. No problems. So, const stitch string by reference rendered well template. This should clarify all of the magic that's going on here. And then we just have to make sure we supply the rendered well template. And now, with a bit of luck, we're going to get what we need. Now, as you probably noticed, this is not going to change things in any way. This is just a refactor to get us in the right position to do what we want. Okay, which is good. Now we fix the problem. So let's then say logical refactor template rendering make rendering and not rely directly on archetypes. Make rendering methods. Okay. So that gives us the first step. The second step then is now going to be to render other things. So we still have very, very large methods here. And you can see that perhaps we could benefit from a templatized method here, because it's going to be exactly the same method, I think. So perhaps we could just have a simple lambda. Can we have a template lambda in C++ 17? Let's look at the solution. Oh, okay. So it seems we can have a template lambda. We just need to have an auto. Okay, auto argument. So let's try to create one of these then. So let's call this a lambda. I'm very creative with names. And let's call it an element. One thing I dislike is that we never get proper indentation on lambdas. Right, let's call that an element, and then I actually like creating my lambdas on the constructor. And then let's just say something like this. All of this goes into here. And so while lambda will say something like, it's even worse actually, I don't know why. Very bad syntax indentation for lambdas. So auto element by reference, and we don't call it E because we know what E's are always elements, and now this becomes e.name.id. The element, we already have it. We are processing id.value. The configuration is e.configuration. The text template. Oh, actually, we probably want to call these templatable elements, but okay, that's fine. We know what we mean. And e.relationship must exist. And finally, e.decoration. The feature model is already available, so we need to capture it. And finally, we just have to set the template. And now, again, we should not expect any changes if we were to just say for each of these lambda pair.seconds dereference. Okay, and just for good measure, let's put a comment here. Process types, and in a second we shall process this lambda could be const because we're not going to really change it. And now I'm just going to move this here, although Emacs is now not going to ident properly, but there you go. Just annoys me that line break there. So this now is fairly generic. And while we're here, let's see if we can do something similar for while mustache templates. Perhaps we don't need it because the whale template population. Oh no, we do. So what are we doing then? Oh, in fact, we've already done it. So doesn't seem to require anything particularly clever. Could create a lambda, but it seems a little bit overkill already, given that we have a one-line function. So let's not worry about that. Okay, so what does the test say? What do the tests say? Seems alright to me. Let's commit this. So use for stitch rendering in template rendering transform. Okay, so there's that. And now, finally, after all this, we should be able to say process helpers. And if I just say here, I wonder if there's a need. Well, actually, what we really need is something like. Well, actually, to be honest, sometimes you go a bit overboard with this aliasing. It doesn't add any value; it just adds verbosity. So here we are. So nicely broken. We have two different types of processing inside of our function. One for the helpers, the other one for the lambdas. Sorry, for the archetypes. Now, I should think things might move, hopefully. This is because we are now rendering the stitch template transform, which means that when we generate the C++ model, it will render the contents. There we go. It will render the contents of the transform. So now what we're going to do is we're going to generate a code generator with this code, and we're going to see what happens. Now what's going to happen probably is that we're going to generate non-generatable, non-compilable code, I suspect. Let's see what we get. Okay. Well, that seems to compile. However, it's not all of it. The problem is, let's generate another code generator. So, okay, just so you understand what's going on here. We generated a generator. The generator is this guy here, and what this thing does is it will generate something. In this particular case, it will generate whatever this thing does. However, the generator itself is not actually doing anything special at the moment, because no one has registered it. And because no one's registered it, it will not will not kick in effectively. So if we understood everything, and I think we do, I think we should just be able to run all tests and it should pass, because there should be no more differences. The generator is there, it is generating some code. Right, there we are. And now what we should say is logical render templates for helpers in template rendering transform. Now that's very good. What we now need to do is open up an area. What did we call this area? LSP. We don't really need an LSP area because LSP is working, so it's fine. So let's stick over that area. What we're going to do now is we're going to do this. We're going to say, let's say I take the new helper. Let's say I take the old helper. So smart pointer helper. So now the old one was just the transform, right? And the new one has got a split for these two. So what we'll do is we'll just do an edif. Oh, actually, before we do that, let's make sure. Right, so let's just do an edif, and let's just say smart pointer helper. Okay, I don't know why edif would give me the same file twice, but thanks very much, edif. So we're going to diff against the transform. Now, that's a good diff. That's a good diff. That's a good diff. And there are no more diffs. So that looks brilliant. It's exactly where we want it. Now then, if I then say, please give me the smart pointer helper in types and give me, now this is where things are going to become quite interesting really. This guy clearly looks different, if you see what I mean. Okay, actually just for the laugh, I'm just going to edif it. The reason why I'm going to edif it is because I want to see if there's differences at the bottom. So this we understand that is different. I'm not sure why edif is not very responsive at the moment. Hopefully my Emacs is not having a bit of a tantrum. But clearly what's happening here at the moment is that okay, so I think we just have a blank whale template actually. Let's try to cancel this. Now what Emacs thinks is doing. Bit temperamental, and that's why I ended up restarting it recently and getting latest of everything. Not entirely sure what's going on. It's never good when your Emacs is temperamental because we rely on Emacs for everything really. I like to always give it a few minutes because restarting Emacs is so painful. But in fact, while that's going on, let's have a look at what we're doing for time. Got 30 minutes, not too bad. Okay, we seem to have... okay, Emacs just got a little bit confused. Let's just quit here because we don't really want Emacs to go crazy. Right, so what do we see here? We see that we're missing a whole chunk of stuff in this template. But other than that, it actually looks fine. The bottom of it looks perfectly fine, which is good. That's actually almost the ideal scenario. Everything is okay, we're just missing this bit here. Now, why are we missing this bit here? Well, it's actually probably not a coincidence. I think that that bit there, believe it or not, comes from the instantiation of the whale template. And I bet you that if I was to look at the CPP helper transform implementation, now I think we still don't have a template area, so let's open one up. Let's go for 7. And if we just go to whatever tend to keep our templates. So we normally always have a mustache template. Not sure why that happened. Right there, as I said, we always have. Oh, I think I'm in diet mode. That's why. Sometimes your brain's just not functioning. Need more coffee. Right, what I meant to do is enter, and then so we always have a mustache template, which you can easily enable mustache mode. I mean, we put all sorts of stuff in the mustache template, to be fair, not just mustache stuff, but what we'll do is we'll put the stitch template here, and we probably don't have a stitch mode enabled, so let's just quickly grab it. We never really got around setting this up properly. We have this very simple, very basic mode. Right, and then we just have to make sure we disable LSP mode. Okay, here we are. Now then, there's the template here. Now what we do is let's get our mustache template here. Now as you can see here, this template looks awfully similar to what we're missing. So what we do then is we'll basically say, are we sure that we are processing the whale template for this guy? Now, how do we know that? Well, we need to go probably to the oops, not quite the key I wanted to press. Probably to the rendering template itself, transform. And I think we merged recently the rendering templates. So I suspect there should be a populate whale template here somewhere. And I think the problem is well, we shall find out what the problem is. Now, so I changed my mind. I'm going to go back to the idea of a lambda here. So const, if I could type. So, I'm really having a bad typing day today. So if we just go back to the idea of a lambda and say something like this, and again we have to do all the faffing around with the syntax. What we'll do is we'll do something like bit of logging. Processing e.name.id, and then we could say please go and populate the whale templates, and you need m, so that's fine, and I will just give you a const reference m. Now you can see you can see that we really are becoming quite generic here, but there we are. And then we can take this lambda of ours after we frigged it a little bit, and now we could just say please lambda this. Now we can do this with just one parenthesis, and similarly this. Okay, so now that makes the code a little bit simpler. And what we'll do then is we will check if this guy has a whale template. Interesting enough, the whale template is optional. So, well, let's just basically say here elements does not have a whale template. Might be too big. No. Right, there we are. So this will give us a little bit of visibility, observability, I guess. Then if it does have a whale template, we'll expect that, and then we should probably say something like populated template for elements. And now we've got complete observability of what's going on in this transform, but at least as far as well goes. And we could just say something like not all templatable elements require a well template. Okay, so if we don't have one, we have nothing to do. So bomb up. No, it doesn't add a lot of value. Okay, so now we remember what we're doing here. So okay, I think that looks pretty sensible. And then what we'll do is, for good measure, we will remember the name of the logger, and we will go up to our CMake lists and enable logging. Now, if I just say something like generate text, Dogen.text sequence.dia, with all of this on, and whilst that's going on, I'll go up to the logger. We are on the right model, I believe. Not the right timestamp though. Have a look. Oh yeah, the timestamp is correct now. Okay, so what we do now is we just basically say, well, give me the log for this logger. It should take a few seconds, given it's 179 meg. Taking a bit longer than expected, to be honest, but I think it's probably because I left it in JSON mode. It's not a good idea, but here we are. Hope the content is not huge. So if I change this to log view mode. Right, so what we want to see now is we want to look for our friend, and we need to see okay, so that actually looks quite positive. We seem to be rendering the whale template. Interesting, we say rendering. Okay, let's look at the comments we put in the log file again, because this is not what I'd expect. How are we doing for time? Squawk never updates. And the video is 43 minutes, so it's not too bad. Now let's just focus here for a second. I was expecting a comment like rendered well template. In fact, I don't think I've seen. But we should really look for something like processing. So I think we are in a bit of trouble. Let's just highlight this guy here, I should think. Perhaps, no, there's bookmarks, F10. I never quite remember what we do for symbols. Let's just go for a highlight lines matching regular expressions, might point to help them. So yellow would do. Okay, that wasn't particularly highlighted. I think it's probably because we're in log view mode. Let's see if highlight symbol works. No, I think it's just to do with the fonts. the useful of you. So we seem to be saying processing, rendering the whale template. See, we say rendering the whale. So processing seems good. Then rendering whale template. But what does not seem so good is that we don't seem to have either this guy here or this guy. That's a bit worrying, isn't it, really? Before we go any further, let's make sure that there is no other processing. Ah, okay, fine. That explains it. So it's not this processing, it's that processing that we're kicking in. Okay, cool. So, let's understand why we're not going through this first guy. It's very unconditional, this work. Let's just make sure that we actually go in. Well, I can't see how this would have worked for a generic case, the archetypes. So we must definitely be going through this. There's something interesting here as well. Notice how... Right, we've done something not quite right here. So the physical elements are const. The pair is not const. I'm not entirely sure that all this const non-const business is a good thing. I don't think it's helping. So I'm just going to remove this alias. I don't think it's making any difference, but at least I'm not confused about the constants here. Besides, it's a pointer probably, so it doesn't care. We're going through all the helpers. Well, I guess the thing we want to know is, are we even getting into this guy here, really? I mean, we have to, really, but populating, resolving, populating all whale templates. And then we could just say populating archetypes, and then we'll say populating helpers. This is more or less how we do logging around here. We never do logging. We tend to do very little logging in the first instance, and then what we do is we have a problem, and then as we have a problem, we add as much logging as needed to solve that problem. Oh, actually, one thing we did not do, to be fair, we did not regenerate the code generator. That was a bit of a mistake, so that might explain actually why we're not getting any logging. In fact, that is probably why. So we will let it do its thing, rebuild this thing. It's now reloading 173 megabytes in the buffer. Let's make sure we don't have any messages coming through. Okay, sorry about that. Now then, we've got all of our messages in here. We'll do exactly the same search, not quite that, but whatever we were searching before. Interestingly enough, seem to have lost it. We were searching for the new helper. Actually, I think you probably guessed already what's going to happen is we're going to say there is no stitch template. Now we got the helper. Okay, this is not ideal. We should probably do a dot value there. So there we are. Right, there we are. As you'd expect, we do not have a well template. Okay, that's fine. At least we now know. I'm just going to take the liberty of saying dot value because it just annoys me. We need to fix the primitives to just output strings, or at least have some kind of manipulator for this. Const out to so if we just make this the logical ID, and then here we just say let.value. We have the Portuguese keyboard here clearly. Right, now then, why don't we have a whale template? That's the good question. But we know for sure. Oh well, do we know for sure? We have a helper family. Not quite sure what exactly that's doing right now, but we shall find out. But more importantly, how do we populate the whale templates? Well, to be honest, it doesn't look like we're populating it at all, does it? No metadata here. Right, so let's start with that. How do we associate a whale template? Well, we could have a configuration, but the configuration is not going to help, I don't think. Or maybe it will actually, because all of the helpers are going to have more or less the same implementation, I think. So what we'll do, let's just create a quick profile here. And colors are DDD, easy enough to remember. And something like, I don't know, helper implementation perhaps. And then we could say, well, probably going to need a part ID, I guess. And I think we probably should just say that the part ID, well, while we're here, let's just make both at the same time, because we shall need the helper header as well as we will need the helper implementation. So both will need a part, not for now, but for the future. And for the header, we would like public headers. For the implementation, we would like the implementation parts. Right, now then, I'm gonna probably have to move somewhere safer. And then for, well, we don't really need locator functions, we delete that in 1 minute. We do need the well template reference. Now, the well template reference is going to be a bit tricky because we have this notion of enabled, not enabled. Let's just ignore that for now. I don't think the headers need well templates because, yeah, that's just basically an artifact of the past. So the header won't need a well template, but the implementation does. And let's just say this guy perhaps. How do we refer to a well template? Just by the name, it seems. So might need a relation status, and whatever the header says, the relation status. Interestingly, right, so the headers have very complicated relation status. Okay, so let's just choose a random one, say class. Do we have a relation status here? Inclusion support. There's a lot of things here that are no longer used. We need to do a proper tidy up in a second. Right, here we are. This is all very, very complicated and unnecessarily so for now. just for now. Right, so we got a few parameters being supplied now, and we just need a bit of space for these guys. Where should we put them? Some space on this side, not a lot on this side. Since this is a bit temporary, I'm just gonna hack it and put it here. There's no point of having any inheritance here, so we're not gonna bother with that. It's interesting that these profiles, I think in the profiles we need something like a stereotype. Here we are, binding point and a stereotype. So not going to bother with comments either, since this is just temporary. So we can call these Dogen whatever helper, and then see, maybe this can be just a helper implementation. Now then, if I was to take, say, the Dogen helper, interesting. Oh yes, of course. So what we need to do is now to go to the implementations. This is where a little bit of concentration is required. So the implementation configuration now changes. So we just have to make sure that whatever we're using right now, Dogen implementation configuration, we haven't missed anything. So interesting to notice that oh yes, okay, so this is not entirely true. I think the factory here this is where things start to get a little bit complicated. This is sadly the problem with this kind of code. This meta code is just, it requires quite a lot of thinking, because you have to remember that there's a generator that generate generators, and there's the generators themselves, and we must make sure we don't configure it at the wrong level. So normally in a normal MD you try to make sure that there's layers you can't cross, but we took a different approach where we flatten a little bit this sort of hierarchical space, and most of the time it's okay, but cases like this makes it a little bit hard to think about things. So what we're trying to say at the moment is we have an archetype, the helper class implementation transform, that generates a helper. Now we don't necessarily want the helper class implementation transform to have associated with it the whale template for the helper. So now you can see where the problem is coming from. The archetype has a whale template, but this whale template is a whale template for archetypes. So it will contain all the infrastructure that archetypes may need. This is not where we want to do the changes. We will generate this code, and then the generated code will generate the helper. The helper somehow needs to have associated with it a whale template. Now, I'm not entirely sure that we've ever had a situation like this. So if we take as an example something like a class has an object edit configuration, and that has associated with the whale template transform, so that's fine. So okay, maybe, I mean, slightly lost here, but maybe. But the difference, of course, with a class versus a helper is that the class is an archetype. Yeah, we somehow seem to have gotten lost slightly here. This is actually quite a complex thing. Seems very simple, but it's not quite that straightforward. So with a class, the class instantiates the archetype, but you can clearly see here that the classes are archetypes themselves, the helpers are coming in as if it were a separate type of an archetype, and we don't necessarily want that. I actually think we're gonna have to do some work offline, I think, because this is actually quite a complex thing. It probably is not that hard. It just requires a little bit of thinking. But let me just describe the problem so that I can at least give a bit of context of what's going on here. So in Dogen, we define every single file that we generate as an archetype. So for example, to take any of these guys here, say a class header, this is the archetype that generates all class headers. And what's an archetype? Well, an archetype just basically binds a logical model element to a physical representation of that element. And you can think of it as the function that is responsible for projecting the logical model element across the physical space with a given representation. Now that's very, very simple. You just take the logical model element, you project it. Now, however, there is a special type of logical model elements that represent the physical elements themselves. And that's where things get tricky. So there is an element responsible representing the notion of an archetype, the generic notion of an archetype. So if you imagine, if you were to think of this in terms of OMG, what you've done is you moved between the layers. You've gone from M2 to M, whatever the M is above, and M3 probably. And what you've done there is it's not exactly to say this is a meta-meta model, but it's similar to the meta-meta model. And the job of this guy basically is to say, well, all archetypes have a similar shape, and so therefore describe the archetypes for me. And what these guys do is they generate archetypes, and you can think of the archetype as the model to text transform that will eventually generate the archetype instance, right? And that guy basically generates the model text transform generically, and it's all fine. And then what it does is, if you're the archetype class implementation transform, it literally just says, please give me whatever content of the template that you've got for the particular element. And that works really well. However, what we've done now is the helpers are kind of like an archetype, but they're not quite an archetype. So we've confused the implementation of helpers in a way, because we've implemented them as if they were a special kind of archetype, as you can see here, a helper, which does not match any of the existing implementations. We've made the logical mistake somewhere. Literally, this should really be MAS.physical.archetype, and then this should bind to the logical model element of helper. But at the same time, because an archetype is similar to a helper, or a helper is similar to an archetype, we may not be able to do that, and that's why there was some confusion here. So what we need to do now is we need to sit down very quietly with a whiteboard and then work out the right structure for these types, and then we will return to these videos when we get there. But hopefully the problem should be quite clear now. And once we've done that, we should be able to start generating archetypes with the right parameters. Because the problem at the moment is that we can't supply the right parameters because we don't know where to supply them. Because as you can see here, the smart pointer helper is representing, in effect, all archetypes associated with the logical model element. And because of that, how can we supply parameters? We can't. So literally, we should have something like helper header or helper something like that, right? And that's really where it becomes quite tricky. Really, you just have to think properly about this. Okay, so a bit of a cop out, I'm afraid, but we will just have to do that. Otherwise, this will take far too long. Okay, thanks for watching. Hopefully, we'll return back soon.